So this first one, we have to take into account the order of precedence of operations. So the e is raised to the power of 9 before the logarithm function happens. That means to evaluate this one, we need to use the power rule for logarithms to rearrange it to this. Now we need to know that ln e is equal to 1. This gives us 9 minus 5, which is equal to 4. For the second one, I'm going to rearrange using, firstly, the power rule. So I'm going to rearrange it to the square root of 4 like this, using the power rule. Then I'm going to use the quotient rule for logarithms. And this we can evaluate to be 2, because 6 squared is, let me do an extra step here. That means we can rewrite 36 as 6 squared. Using the power rule, we get 2 log base 6 of 6. Log of any number to its base is 1. Then we'll simplify down to 2. What we got here. So here on this one, we need to use the power rule first, and we get 7 times 2 ln e minus log base 12 of 12. The log of any number to its base is 1. ln e is also going to be 1, so we get 14 minus 1, which is 13. Oh, I could definitely do, all I'm looking for in this one, for a solution, I think I'm working on this one. I'm going to go from here to here to here. That would be my solution that I would write. I'm showing a lot more steps to see the logic of it, but that would be what we would expect to sort of see from the solution. Does that answer the question? Have a go at these questions in 5 minutes. Okay, so solving these. So here on the left-hand side, we're going to use the product rule for logarithms to give us log base 6 of 18x. There on the right-hand side, that's not in the log base 6. I want to make it log base 6. So what I'm going to do is I'm going to start by taking the log base 5 and writing it as 5 squared. That's 2 log base 5 times 5, which is 2. So 2, what have I got? I've got log base 5, I'm going to 2. So I want to write log base 6 of 36, because that's also 2. Now I've got a log on both sides. I can do the inverse function to log, which is 6 to the x, and it'll give me 18x equals 36. X equals 36 divided by 18, 2. At this point, check your solution in your original equation. Are we creating a negative with this answer? No, we're not, so we're good. Check for extraneous solutions at that point by taking that number, putting it back into any instance of x in the original equation to make sure you don't produce a negative. Here on this second one, we should always interpret this as being like this. It's the logarithm of 12, and we subtract 8. It would have to be written, if this was in the brackets, why would you write it? Firstly, not just go straight to 4, so it has to be written. This is how you interpret this. So for this one, what am I going to do here? I can bring, using the power rule on the right-hand side, log base 2 of x squared, on the left-hand side, sorry. And then on the right-hand side, I want to join those two. So what I'm going to do for that, I've got log base 2 of 12 minus log base 2 of, well, what, 8, that would be 64, wasn't it? 2 to the 8 is 64. So I can write it like that. Let me just add an extra line over here. So it's log base 2 of 12 minus, and we want 8 times log base 2 of 2. So this is how you think. And then when we bring the 2 in, we get 2 to the, when we bring the 8 in, we get 2 to the 8, which is 64. So now we can rewrite this as log base 2 of x squared minus, equals log base 2 of 12 over 64. Take 2 to the x on both sides, the inverse function, and we get x squared is equal to 12 over 64. Square root both sides, and we get x. Oh no, simplify both sides first. Let's simplify. We'll get x squared is equal to, divide everything by 4 on the top, will give me a 3. I'll divide everything by 4 on the bottom, gives me 16. Square root both sides, we get plus minus root 3 over 4. Now, check for extraneous solutions. Here, here, check for extraneous solutions. That x can't be negative. So we would need to say that log x implies x is greater than 0, which implies x equals minus root 3 over, plus root 3 over 4 over.
So, how did you get log 264?
I'm here. So here on this one, log 2 of 12 minus log 2 of 2 to the 8. That's not 66. 256.
So it would be.
So it sounds a question.
Okay, I see.
I'm just saw a handful.
That would be 64, wouldn't it?
Seriously, that would be 100.
So that would be 8. So
What's the
no, let's that would be 56. That would be divided by 4 would give us 3 over 64. That would give us plus minus the square root of 3 over 8. There we go. Am I correct now? Okay. Have a go at this question for a few minutes. Let's have a look. So we have 54,000 grams of, 54 kilos of radioactive kind of iodine. How much will be left after 106 minutes if its half-life is 53? So what's going on here?
Basically, half-life means that half of it is gone, like half of the substance is gone.
Usually half of the substance doesn't go. What usually happens
it's split up into another
Usually what happens is you've got an iodine chemical, and there's an imbalance of electrons and protons inside the nucleus. And after a while, some of these are emitted, and it emits a small amount of energy or a large amount of energy, which is radiation, and one of the neutrons or protons leaves. The iodine remains, but it's no longer the radioactive form of the isotope. It's a more stable isotope. That's what radioactive decay is. So half-life is how long it takes for it to halve. So if we have 54,544 grams and we want to halve it, we times it by 0.5. So this is how we can do half-life. So we want to times it by 0.5 to the 1. If we want to make this into an equation, we need to find out how long it would take to do something. We need a variable up here. So we want to have something on the lines of the current amount being equal to the initial amount times 0.5, and then we need some kind of A times T. Now, the half-life of this one is 53 minutes. The half-life is 53 minutes. What does the value of A have to be? So that when we put in 53 into T here, we're going to put 53 in there. We need to fix the constant so that that becomes 1. What does, don't shout it out, people can do it on their own. What does A have to be? We want to put in 53 as T, and we want that exponent to become 1. So it halves it. What is the value of A? Let me take a moment. Negative. Wouldn't that give us -1?
Oh, yes. 1.
Yeah. So we would want T here, and then we would want 53 there, divided by 53. So your general form for this is going to be the time over the half-life. That will then, if the half-life is 53, when you put 53 in, you'll get 1. If you put 106 in, you're going to get 2, so it will quarter. And that's the answer here on this question. We've got 1 minute left. Does everyone know what heard of half-life before? Half-life is used in carbon dating. Carbon dating is the process of dating old objects and finding out how old they are. Works quite easily. In the atmosphere, all the time, there is a set amount of carbon-14 in the air. So every living organism breathes this in, and it's radioactive. It's an unstable form of carbon, and it will decay over time. I think it's about 512 years, the half-life of carbon-14. So what happens when an organism dies and it stops breathing? If it's not breathing, it's not taking in any more carbon-14, so the equilibrium is lost, and it will start to decay in the body. So you can measure the amount of carbon-14 in an object in order to determine how long it's been dead. So whether that's a piece of parchment or a piece of cloth, that was once part of a living organism that is now dead. Carbon-14. We can use that for carbon dating. The carbon levels in the atmosphere have varied a little bit over time, but the scientists now have a model of what the different levels are, so they make slight adjustments, and they get reasonably good predictions from organic materials. It doesn't work for inorganic materials like stone, metals, gems, but it does work for organic ones. All right, homework for this week, for today, is a couple of wordy problems like this one we just did. That's it for today.
So how